Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if intelligence tests measure everyone the same way, or why some people seem to grasp things faster than others? Well, this new study dives deep into that very question. This massive study looked at how something called general intelligence, often thought of as our overall smarts, affects how well specific thinking skills work. And it turns out the answer isn't quite as simple as we might think. It is like asking, does the main highway determine how fast every side road is? Well, maybe not always. So these scientists were really curious about something called cognitive differentiation. Think of it like this. When you have a bunch of different cognitive skills, like memory, problem solving, and focus, they're usually all a bit connected. This connection is often tied to our general intelligence, or G, as the researchers call it. But does this connection always stay the same for everyone? Or does it change depending on how smart you are or how old you are? That is the big question here. To get to the bottom of this, they did something pretty amazing. They gathered data from over 42,000 kids and teenagers who took part in 20 different official tests that were used to set the standards for those tests. This is like looking at a huge group of people from all walks of life, all tested in a very thorough way. They called it an individual participant data meta-analysis, which basically means they pooled together the actual test results from many separate studies. This is gold for getting a really clear picture. Now, how do you figure out if general intelligence affects specific skills differently? They used the fancy tool called nonlinear factor analysis. In simple terms, they looked at how strongly each specific thinking skill was linked to general intelligence. They called this link AG loading. Then they checked if these G loadings changed based on a person's age or their level of ability overall. Did being super smart make the connection weaker? Did being younger change it? They tested all of that. It is like seeing if the highway's connection to the side roads changes, depending on how big the main highway is or how many lanes it has. And here is where it gets really interesting. They found that as people's general intelligence or ability level went up, the G-loading became weaker. This means that for people who are generally very bright, their specific cognitive skills are less strongly tied to their overall general intelligence compared to people with average or lower general intelligence. Essentially, it seems like really smart people's specific abilities might be a bit more independent. What about age? This is where it gets a bit less clear. The study didn't find strong evidence that age itself dramatically changed how general intelligence related to specific skills in children and adolescents. The effects were pretty mixed and didn't add up to a consistent pattern. So it seems age might not be as big a player in this particular connection as we might have thought. Let's dig into that ability level finding a bit more. Imagine a test designed to measure thinking skills. For someone with average intelligence, the test might be doing a great job of measuring their general intelligence through tasks, covering various skills. But for someone with very high intelligence, the same test might not capture as much of their overall general smarts through those specific tasks. Their unique strengths might not be as connected to the G factor that the test is trying to measure. This finding is actually quite important because the connection between general intelligence and specific skills is what we call the positive manifold. And it is a foundational idea in intelligence research. What does this mean for us? Well, it tells us that when we assess intelligence, especially for kids and teens, we need to be careful. A standard IQ score might not be as precise a measure of general intelligence for someone who is exceptionally bright. It is like trying to measure the exact speed of a Formula One car using the same speedometer you'd use for a bicycle. The scale might not be sensitive enough at the highest end. The researchers suggest we need conditional reliability estimates, meaning the accuracy of the test might depend on the person's ability level. This is the core takeaway as stated in their public significance statement. Intelligence tests are great, but they might be less precise in measuring general intelligence for kids and teens who are already at the top of the ability spectrum. And that is crucial for anyone who uses these tests, like psychologists or educators, and for scientists trying to understand what intelligence even is. This study suggests that general intelligence and specific abilities are connected, but that connection isn't a one-size-fits-all deal. The ability level of the individual really matters. To understand where this research came from, it is helpful to know about differentiation research. For a long time, scientists tried to study these differences by comparing groups of people already separated by age or ability. But more recently, with advanced statistical tools like the nonlinear factor analysis they used, they can look at these things continuously without needing preset groups. This makes the findings much more nuanced. So this study is a big step forward because it uses these modern methods on a huge amount of data, trying to clear up some of the confusion from older studies that had mixed results. They controlled for a lot of things like sample origin and analysis methods, so they could really focus on ability and age. They used specific measures like lambda 2, lambda 3, and lambda 4 to represent the strength of the ability differentiation, age differentiation, and their interaction. Don't worry too much about the Greek letters. Just think of them as numbers that tell us how strong those effects are. Looking at their detailed results from each sample, which they presented in Table 4, you can see all sorts of patterns. Some tests clearly showed ability differentiation, meaning the link between general intelligence and specific skills weakened at higher ability levels. Others were less clear, but when they combined all the data in their mega-analysis, as shown in Table 5, that overall trend of decreasing G-loadings with increasing ability really stood out. The meta-analytic lambda 2 of negative 0.046 was statistically significant, meaning it is very unlikely to be a fluke. What does that number mean in plain English? Well, they calculated that for a 2 standard deviation increase in ability, say from an IQ of 70 to 130, the connection between general intelligence and specific test performance could be more than 4 times weaker at the higher IQ level. That is a pretty significant drop. And for age differences, as I mentioned, the meta-analysis showed a lambda 3 of a tiny 0.003, which is not statistically significant. This means age didn't reliably change this connection across the board in their study. They also looked at whether the ability differentiation effect itself changed with age. They found a small negative interaction effect, lambda 4, but again, it wasn't significant. So, while some individual groups of kids might show this pattern, it wasn't strong enough across the whole research to say that the way intelligence differences play out changes systematically as kids get older within childhood and adolescence. So, the biggest story here is that ability level is a really important factor. It is not just about how smart you are in general, but how that general intelligence relates to more specific skills. For those with higher abilities, the unique skills might become more distinct from the general intelligence factor. This has serious implications for how we test and understand intelligence. If tests are less precise for very bright kids, we might need to use different interpretations or even different types of tests for them. Imagine a doctor using one thermometer for a baby and another for an adult. The tool needs to be appropriate for the individual. Now, no study is perfect, and it is important to look at the limitations. This study focused on German tests and samples. While they included some nearby countries, we can't automatically assume these findings apply exactly the same way everywhere in the world. Different cultures and educational systems might influence these patterns. Also, they only looked at children and adolescents. What happens in adulthood or in very early childhood before these tests are typically used? Those stages might have their own unique ways that general and specific abilities interact. What is next? The researchers suggest we need to look at other aspects of differentiation too, like how the importance of specific skills might change. They also want to see these studies done in different countries and with different age groups. So to wrap it up, this study has given us a clearer, more detailed picture of how general intelligence influences specific cognitive skills in young people. The main takeaway is that how strongly these are linked depends a lot on a person's overall ability level. For those with higher abilities, their specific skills might be a bit more independent from the general intelligence factor, while age seems to play a less significant role in this particular aspect. This is really important for making sure our intelligence tests and our theories about the mind are as accurate and fair as possible for everyone, no matter their ability level. What do you think about these findings? Does it make sense to you that the link between general and specific intelligence might change with ability level? Let me know in the comments below. And if you enjoyed breaking down this really cool science with me, please give this video a thumbs up and subscribe to RUBIN'S Mind Lab for more explorations into the fascinating world of psychology. Thanks for watching, and I'll see you in the next one.